here. Today we are going to talk about 3D printing service bureaus and basically interacting with many of the great leaders of these service bureaus, and in terms of current realities and what are the future possibilities with these service bureaus here. Um, Service bureaus are one of the best basically play for any company to start the to start this technology journey and learn about new technology, get access to this technology quickly, as as when it comes to a 3D printing service bureau. But also it happens so that these service bureaus, they take bigger risks. They invest in great infrastructure, great machines, technology, and take that initial risk. For all of us to move this technology adoption, into this, especially with 3D printing, much faster. And they are the accelerators or catalysts in making this technology reach, additive manufacturing technology reach to many of users in industry now. Um, but also it happens so that the bigger companies are now having their own machines, buying their own 3D printing setups, and that also puts service bureaus in a risk. And continuously, cautiously, they have to reinvent themselves, ensuring the business is sustainable for them, their customers, and for the whole industry. Learning from the heads of these service bureaus, um, we will be talking about um, how we can leverage each other's strengths or technology in order to go ahead and stay ahead of the curve in India. And at IMF, it started, Indian Additive Manufacturing Forum, it has started with such vision of creating, building community of, around additive manufacturing in India, wherein we build synergy, we build, an ecosystem where we leverage each other and grow together. And one of the most active network we have here, of AM professionals in India is IMF. IMF was basically started by a few entrepreneurs. It's a non-profit, Indian Additive Manufacturing Forum. It's a non-profit. So it was started with an intention of basically uh, bring together all the stakeholders of to common platform, wherein we promote overall growth of additive manufacturing technology in India, and further address the needs of members and industry, to irrespective of their affiliation or of company or size. It can be an individual, it can be a company, and then grow together, share knowledge, bring in more opportunities. And that is where we as IMF, we work together here. Many of us in core team, are either company owners and running our own businesses, being part of many such businesses around AM. And we have got an amazing team here who's leading this, led by our president Parth. So today, we have, this session is going to start with one of the, very interesting speaker that we have, who does not need any introduction, but I will still introduce him. His name is Ankit Sahu. He's a director of Objectify Technologies, and he's been into this industry since 2013. Ankit, he has pursued his bachelor's of engineering in 2010 in mechanical engineering from RV College, Bangalore, and post that he's done his manufacturing technology engineering in Warwick University, UK, and in 2013 through SIIC Incubation Center in IIT Kanpur, he started Objectify Technologies, and from there they've been working with many companies, many organizations across India and globally as well, and leading 3D printing service bureau in India. I have Ankit Sahu here. Good morning, Ankit. You're on mute. Yeah.
Good morning, Swapnil. It is my pleasure to be here today, and thank you for inviting. And I really have been following you guys for a very long time. Actually, the irony of the situation is I wanted to join this organization when we started, and that time I think Gopal was there, and something went wrong. So I was not a member directly, but yes, uh, I had been following all the activities which surrounds IAMF. So thank you for inviting me in this. So can you see my presentation if it
Yes,
is?
we can. Yes, we can.
Yes. So, so today, Swapnil, I just wanted to talk about the 3D printing technology being used in the defense and the aerospace side of the things, and the current scope in the Indian context. So when we start talking about how and why people want to do a make or buy kind of a decision, and where a company like Objectify comes into thought process is mostly on the core competency. The major problem with the technology has been the mis-selling, the mis information kind of a thing, where it has been difficult to teach our customer to unlearn a lot of things before pitching something to them. So that's where like I want to start, and that's where like somewhat we have been successful in doing so for our customers. And most of our customers have we have been working in a lot of aerospace and defense level application, and where the high value component is, it's a perfect risk and it is a perfect opportunity. So working on a high value project is something like we really enjoy now, because now we have learned a lot in the process. So so I wanted to introduce you about Objectify Technologies. So we are one of the leading additive manufacturing engineering service providers in Asia. One of the biggest setup, excluding China, if you can say. We were founded, as Swapnil already mentioned, that we were founded in 2013 with the agenda to facelift the manufacturing process industry. We serve most of the aerospace, automotive space, oil and gas, dye and mold applications. Our critical component mix is from design for additive manufacturing, low volume, high value critical production. So that's why like we have found our sweet spot, and we work with more than 800 plus customers. So this is how we started. On the left hand side with the MakerBot Replicator 2x way back in 2013. This is me in IIT Kanpur Incubation Center, where we started working on some of the institute projects. And I like the beauty of the situation was like our first commercial order was from a drone manufacturer, so an aerospace order, from which we started. So but currently now this is our Noida facility, the current Noida facility, where we have all our metal 3D printers. So we have two facilities, one in Noida and one in Delhi. So the Delhi facility is the complete polymer facility, and the Noida facility is the uh, metal facility. So we have been doing a lot of project work for our end customers. So this has been like our journey, and you can see the timeline has been very coincidental with a lot of major updates and projects which we have been doing with our customers. So since 2015, since we moved to Delhi, started our industrial level focus. So we had an opportunity to work with a lot of blue chip customers like Havels, Maruti Suzuki, Hero Motocorp for a lot of development projects. In 2018, 19, 20, actually we worked a lot on the BS4 to BS6 transition. So you can name any of the Indian OEMs, Indian automotive OEMs, the engines. All were developed at Objectify Technologies. And at a certain point, we held an IP worth more than like 350 crores at a time when the BS6 development was in full swing. So you can understand that the amount of trust our customers were focusing with us. That's where like A lot of activity started. Then an interesting case came in 2018 from one of the leading FMCG customer, if you can say. The name was Coca-Cola, and they wanted to digitize those 300 ml bottle plant, and that's where like we started working on digital inventory. We started working with the likes of Reliance, the Aditya Birla, the Vedanta Group for digital inventory, where we thought like it's not just printing a new product development, but we can go back and start doing reverse engineering and actually work on the design side, work on a lot of material reverse engineering, material development side. So it has been a more like a customer focus kind of a thing, and we have been trying to push our agenda on those lines. Then we started working also in 2019. Somewhere around that time we started working with global oil and gas companies, so with the likes of Shell, Exxon Mobil, Petronas. We started working with them, with the OEMs like of GE, Baker Hughes, Siemens and Flowserve. So it started pushing that agenda on the oil and gas side. So currently we can proudly say that we have certain impellers working in sub-Saharan temperatures and sub-Siberian temperatures. So you can understand the difference of working on material properties and developing those for the technology itself. And 2019, we also qualified our first space component, a flying component for the SSLV. So it is launched in 2020 during the core of the pandemic, and we had a successful launch. And in the SSLV, that is a normal component now, utilized by the uh, uh, organizations. And we started also working with the Israeli defense and the aerospace market. We started working with the likes of Boeing, Collins Aerospace, Honeywell, Pratt and Whitney, and we started helping the Indian private space Elon Musk's, so to say, that the sky routes and the Agnikul, where we started developing those critical components for the engines they were developing. And that has been a good coincidental thing that our timeline matches to a lot of countries focus changing in the manufacturing setup. So it is a great feat. So our customers have been ranging from automotive, aerospace, defense, oil and gas, the white goods, the medical, and some of the other industries. Our current customer mix is almost like 800 plus customers all across the globe. 30% of our revenue is from global market. And so I want to talk about the space first. And this is a wonderful component to talk about. This is now, as we can say, that in future any of the fuel injector for any of the space programs will be 3D printed. And it is not a bold statement to make, but it is a wise statement to make. So you can understand, earlier something like this had a lot of design level troubles, had a lot of manufacturing level troubles, but additive manufacturing is able to solve that as a problem. So people say the technology is expensive, making components through this technology is expensive, but we should always ask ourselves and our customers that where and exactly what kind of components you want to focus. And this is a wonderful case where actually the cost for manufacturing this component has reduced, the time to manufacture this component has reduced, the efficiency of this component has increased through additive manufacturing. And currently we do like more than like 300 plus fuel injectors every quarter kind of a thing. So you can understand the requirement level increasing in a design like this. Then we can also talk about high value volume or low volume critical components such as nozzles. So so we have changed to more than like 600 plus nozzles in only Aditya Birla. You can understand these nozzles for gas mixing, for fuel mixing, for uh, the chemical mixing we have been changing, and it is now being produced through additive manufacturing. Something like heat exchangers, we have been working with oil and gas customers, the aerospace customers, the space customers for heat exchanger and optimization on the design side. Then the manifolds, so weight reduction is something very interesting in additive manufacturing, and that's where we have been working on manifolds for reducing the redundant weight. So there have been certain cases we are able to reduce from uh, up to like 35 to 40% of the weight. Then impellers were really technological advantage over conventional investment casting, as what we understood with our customers when they came to develop something like an impeller. What we understood that these impellers earlier were done through investment casting, where the major trouble was on the porosity level, on not being able to understand the flow of the material in during the investment casting. So a lot of wastage was there. So now through additive manufacturing, the homogeneity, the monolithic structure of additively manufactured impeller is quite robust, and you get a 99.5% complete homogeneous dense component. So the reliability, the quality, the efficiency of the process can be viewed with something like an impeller. So as people understand that additive manufacturing has been getting along with the industry, the major thing has been the business case around it, the material case around it, the design case around it. So you can understand like how you want to start. So you can start with a spiral of design, then work on the material, then create a business case around it. So these are like some of the projects which we have been able to deliver really well. So I want to also talk about a certain case in high pressure turbine blades. So you can understand that this turbine blade has a conformal cooling channel of almost 1.5 mm. So and it is conforming to the design, to the to the design of the curves of the blade, and so you cannot manufacture it with any other technology. Something like a donut shape, a toroidal gas bottle. So earlier the customer was making it into two halves and then welding on the seam of it, and because of that there were a lot of leakages, there were a lot of failures uh, in the process side. So what we were able to do is like a small design change to make a teardrop structure, and we were able to realize the donut shape uh, directly as a monolithic structure. So no failure, no welding process. So you're reducing on the process, you're reducing on failures, you're reducing on the time to test again and again, and it is a proper monolithic structure. So you can understand like how this agenda has been pushed forward for our customer. Then this is a wonderful case where the customer was making this flame tube into a sheet metal work. So it used to take like more than like 6 months to 8 months to make one flame tube. And the problem of making something like this was like you have so many fasteners to be done, you have so many welding to be done, so much brazing to be done. So what we understood is like if we design it really well and we are able to make it into one single piece, then it will be a wonderful thing. So this is almost like the lowest thickness of this flame tube is almost like 0.8 mm, and the highest thickness is 2.5 mm. So you can understand on a thin structure of a circular this thing. So we were able to manage the warpages, we were able to shorten the lead time, we were able to shorten the complete supply chain. So you can understand how and why to use AM, and where exactly it focuses and increases the project output. So this is for the Hindustan Aeronautics Limited. The This is for the turbo fan engine for the Chetaks, and we have been developing this really well for our end customer. So when we talk about AM, and the bigger problem for most of the customers is like how to define the cost matrix and everything, because everybody ends up with a purchase person, and the purchase person is only interested in discounts. And that's why like we can have certain justification to be done, where we can focus on making him aware of how to work on indirect cost saving and indirect cost appreciation through the additive manufacturing technology. So you can understand from this case study, this is a diesel mixing unit for an automotive application. So the annual requirement for something like this for an automotive customer is almost like 3 lakh pieces. Um, but through AM technology, it's almost like 700 to $800. Uh, but to make something like five offs or the 10 offs, he's he's supposed to create a die casting tool which is worth like 80,000 dollars, and then he will be able to take out 10 to 12 parts, but he'll be investing a lot of time, too much upfront cost. So that's where like AM can help you save that risk, where you can have low volume for your test and trials. So something like this. This is a wonderful case where AM can be compared to CNC machining. So again, like when you machine titanium, uh, so something like this, you are milling out more than like 85% of the material, and a material like titanium, which is very expensive, and it is not environmental friendly to remove so much material and create so much waste. So what you do is like you create 3D print near net shape structure and machine the CTQs, the critical to quality dimensions, and it becomes an easier feat, a better feat on the cost saving side, on understanding uh, on the material saving side, and the cost and the quality of the product can be retained, and this near net shape can be utilized for your end use itself. So as I told you, what people have misunderstood about additive manufacturing is it is a technology which can produce anything and everything, and but generally it works on the principle, a basic principle of garbage in is garbage out. So until unless you spend a lot of time on your pre-processing and the post-processing side of things, which becomes like a project management. So that is the clear-cut secret recipe of success for any of the organization. So as Swapnil was mentioning, that a lot of OEMs are planning to install 3D printers. Yes, they are, but the recipe to make the part right and the risk to make it in-house just to save on the cost is something like a different kind of a scenario, where customers have to be really comfortable, and this project management is the key to success. It is the catalyst which behaves for any of the success of the project itself. So as much as people can guide you, as much as the machine OEMs can guide you, that hey, you take this part, take this design, and you can produce a wonderful component and you can use it. But who will talk about the quality and the reliability question of the customer? So those are some things where we come as a consultants to it. So something on the pre-processing side, the traceability is very important, the support removal, the layer thickness, the post machining thought process is very important. And that's where like we work a lot with our customers and with our development team. So we do a lot of process simulation through MSC Simulfact softwares, and where we have been able to create a lot of compensatory geometry, and we are able to mitigate risk of failures. So any failure has a lot of cost. So we want to save on the cost front itself. So we utilize a lot of simulation packages. Then on the post processing side, it is very important. So you can see this is one of the example. This is one of the largest impeller. What you can say is like produced through AM technology. This is a 380 closed impeller, and it has been operational in sub-Siberian temperatures, currently in SS316L. So it is almost like 78 kilos of impeller in one single print. It took us almost like 5 continuous days of printing to make this. And so you have to do a lot of planning because a lot of investment will go around. So post processing is something which you have to decide before actually taking up the project itself. And that's how you go up being successful in delivering this final end product to your customers. Then the GD&T part, which is the key to success, where the design, the strategy to make it, the virtual simulation, the in process quality control, the post process quality control behaves the most important aspect of the things. Then earlier, like before we were doing simulation, we used to orient the part. We used to create support. We used to assign parameters, and we used to just take it out and find out the part has failed during the print. But after introduction of the software systems, the simulation, we are able to optimize our support. We are able to reduce our support. We are able to change our designs. We are able to create compensatory geometry for the final success. So there is an intangible level of profitability hidden with the simulation packages. So I wanted to also give you a certain example of how to select orientation for an additively manufactured component. So the main reasons of doing so is like to create low stress concentration, to create risk-free brittle fractures, to create risk-free recoater collisions. So something like this, what we do as a study for creating a orientation study for us. So there are certain strategies what we take up, and then we rate them, and according to that we found that strategy 4, which is not exactly the most economical, but it has low distortion, low fracture, low collision. So we select that as a strategy and make a successful print out of it. So this is how you move ahead in developing your components. So what is AM requirements, and how we see this as a organization, IAMF can help. So it is all about education. So what I can say is like these are the 4 pillars of understanding any of the AM technologies and pushing the agenda forward. Is on the design strategy, where you understand on the design side, you work on the design layouts, your CAD and your simulations. Then you do a lot of planning and scheduling, how to do what process at what level. And that is very important to utilize your resources, because as a service bureau, your resources are always constrained, and you need to utilize your resources really well, and you need to schedule your resources really well. So the production strategy has to be really right, and you are working on a lot of high value projects, so any kind of failures has a lot of financial implication. So that risk management has to be dealt really well. So if you take all these 4 points for engineering, that's where Objectify is a bit different from other organization, and we have been a bit successful uh, in metal additive manufacturing because of following these 4 mantras for us. And that's why like I just wanted to close this with our case study. So this is a weight reduction case study through Apex Generative, what we have created. So this is a space rocket manifold, and we have been able to reduce the weight from 21 kilos to 15 kilos. And you can understand carrying each and every 1 kg through ISRO is almost like 7,000 USD. You can understand taking anything in the space from ISRO is like 7,000 USD. So per kilo. So you, if you are saving like 7 kgs in one of the rocket, and in one of the rockets, almost like 12 units are required. So 7 into 12, you are almost saving 100 kilos. And you are saving like for your end customer, you are saving like good amount of $700,000 worth of money for taking those payloads to that orbit. So you can understand a lot of design work, a lot of efforts on FEA, a lot of simulation, is required, and it is also on the trust of the customer. So that is something you people get with the process and with the time itself. So I wanted to thank you for joining today, and I'll be happy to take any questions for now.
Um, thank you, Ankit, for wonderful presentation. Um, if we can, get some questions. Let me see.
Can I stop sharing?
Yeah, you can go ahead. So I wanted to just, one question that I always had, Ankit, for you was in terms of, connecting with especially Indian defense and even, ISRO and working with them, convincing them to adopt new technology and, especially designed for additive manufacturing part is completely different, and the methods and the way it is being done is completely different. How was that journey for you? And because I think it must have taken a lot of time qualifying these components, your material process and making them understand everything. How did it go for you, and what kind of effort it took?
So the basic thing is like anything which is sold cannot be sold. Anything which is not sold can always be sold. So that is the thought where we mostly I and Arpit have been working, and that's where the major thing has been the secret to success is like discussion and creating that trust with the customer and creating that use case. So a lot of problems have we have gone through with our customers, but that has to be really well dealt. So the liability, the risk and everything, that if the customer is ready to share, then it is a wonderful thing. And most of our customers, luckily for us, have been ready to share those risks. So that risk taking ability of your customer is like you have partnership in heaven kind of a thing. So that has been like really good focus. So as I can tell you, like you asked about aerospace and defense, but I can tell you like you also work with a lot of automotive customers. And in India is an automotive manufacturing hub, period. Like we don't manufacture anything else other than automotive, pharmaceuticals or something like that. So the knowledge base of an automotive customer is the highest in the country. And to convince an automotive customer for the technology is the hardest. So 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 I feel not on the aero and defense we had that much problem. Yes, it is much more on the government side, but unless it is automotive, we had faced a lot of troubles. And that's why like that gaining that customer confidence and gaining that respect is where we have always been.
Great. We have some more questions for you, Ankit. One of them being from Priyesh. What is the biggest challenge for you to move towards industrialization of additive?
The biggest challenge, see, looking at hindsight, everything looks good, right? But the biggest challenge has been like taking that right decision, taking the decision of expansion. So if somebody asks like how and why you started, I think Swapnil, you will also not be able to answer it looking backward, because it becomes lot of haziness. And but you can say that I took this decision at a certain point, but those decisions have been much more, I told you, lucky for us with our customers. And that evolution of those user case with our customers have been evolving. So it is not just we have taken right decision, we have taken a lot of wrong decisions also. I think COVID was one of the biggest trouble for the industry, but lucky for us, we had changed our focus, and actually COVID gave us a lot of time to rethink our strategy and come out really well as a process. So we did a lot of webinars, we did a lot of education for our customers. We did engage with a lot of developmental work on the material side, on design side. So being there for your customers is, I think, the basic important part of being in industrial this thing. But people generally end up taking a business decision than uh, a technology decision. So I think you, me, or Priyesh bhai, or anyone, we started as a technology person and we end up now being a businessman, as you had initially said. But that if you become a businessman, your risk taking ability lowers down. You are looking for ROIs and everything, and that's where like everything goes wrong. And till the point you are able to be your technocrat, then I think things will improve. You will take wrong decisions, it's all right. Everybody does that.
That's great. I think I completely agree with you on that. We have some more questions. Parth is asking, what were your biggest challenges as a business? In terms of your journey, and you've come a long way now as Objectify. What was the biggest challenge you faced in the business as a business?
So the biggest challenge in a country like India is access to capital and access to the real manpower. So in India, everybody likes to talk on Make in India and all those things, but where is the support for manufacturing? Everybody wants things to be done. So in the recent tenders, recent things, you have to declare what are the things done indigenized. But where is the ecosystem to do so? So the basic problem of India is the basic problem of any organization, I believe, is on availability of resources, availability in resources like funds, working on human capital, working on the technology side of the thing. So that is the biggest risk of what we have understood. And the other challenge, what we think is like in your head, is like too many questions. If somebody would ask you, like, why did you start divide by zero? I believe the basic reason will be like, all right, I thought it will work, and we started with something. But people will come out with their different stories, but I don't believe them.
Yeah, I mean, I agree with you. Amazing. I mean, in terms of you've been leading in the space and aerospace, in AM space in India. I have a question from Jagjit Singh ji. Do you feel that relationship with ISRO, Agnikul, Skyroot, HAL have opened doors for you, for abroad as well, maybe for exports and, industry abroad
So,
as well?
so 2021, we closed more than 30% of revenue export. So you can understand that, and that ratio is increasing. The pie is also increasing. So the amount of work what we have been doing. So like I will not say that those were like stepping stones for us, but those came in at the right time for us, kind of a thing. And currently, that exposure has created, like, we have understood a lot of like QMS level requirements of these customers. So it becomes easier that Objectify is ready for an international customer. So we export to Collins Aerospace kind of companies, to Boeings of the world. So you can understand that is the level of documentation is required to work with
Yeah.
somebody like that.
Okay. And in terms of, we have a lot of questions quite quickly. I'll just take this up. Um, So do we have a composite metal 3D printing technology where multiple layers of different metals can be printed in one single part? And how feasible or how you know um, uh, real this can be? I mean, in terms of delivering actual application.
So will be a primary production technology over top of it, secondary technology to be done, something like on top of a laser powder bed manufactured component. You can go with a cold spray technology like coatings, or you can work on a wire arc for winding kind of application. But if some lot of things are in academia, TRL level, like technology readiness level 2 3, 4 kind of thing. If somebody is saying that they can print together, I have not seen anything till now on
Yeah.
those lines. But with binder jetting, there are, so everything is TRL level 3, 4 kind of stage. So not ready, but yes, they might exist.
Oh, okay. One more very interesting question we have again from Digjiji is that, as an Indian player, does it give you any advantage over European players or American companies? Say in the service sector, we have manpower cost and advantage as an advantage being an Indian company. What would be the advantage for us as Indian player in AM? Because we will
Being
be
being
having, yeah,
being an Indian player to a European customer is a disadvantage. I will tell you, it is what our forefathers have done in the manufacturing, have created a lot of troubles for the future generation of the quality level and everything. So if they ask a European supplier one question, they will ask you two, and your documentation increases quite a lot. So commercially, yes, it is a good space to be, but on trust level or understanding level, they don't trust right now anybody to produce something out of India.
okay. So how do we I mean, because you said you have around 30% of exports that you've started with. How could one do that as an Indian industry? Because I guess it's a huge market out there and a lot of opportunities are there. How do one approach this market and in various sectors? What will be the way to
One
do that?
step at a time is something like very important.
Okay.
Not to eat too much, which you cannot chew, kind of a thing. So one step at a time. Focus on sample industry, and then spearhead that industry, and then move into the other one. So that is a good part. Like I told you, it's not about the technology, it's about the people and the technology. And
Right.
the bigger problem has been additive manufacturing. People, I don't know for what reason it is a standalone industry. We have a national strategy for additive manufacturing,
Yeah.
which I've never been able to understand. We never had a strategy for manufacturing, and we have a strategy for additive manufacturing. So that people don't care if it is additively manufactured or conventionally manufactured. They want a working component with a
Right.
certain user case, so they don't care about these things. And that's where, like, this technology has been missold really badly. And that's where the customer, the user, or the purchase person, when you talk, they don't care if it is made out of additive or it is CNC turned or milled or something, until unless it's being used for the purpose it has been used for, it is good. Otherwise, like, I don't think so anybody cares about being an AM part or not being an AM part.
Right. We have some of very interesting questions again, because you said a lot of times we come across these purchase people who many of times don't even understand and don't want to understand how you are producing that part, what technology goes into it, and what kind of design process and everything goes into it. One interesting question that we have here is, maybe you mentioned that you've reduced the weight of the component from say 21 kg to 14.9 kg or so on and so forth. What is the cost implication here? Because manufacturing process, to do that, when it comes in to a level where in purchase people, purchase teams are making decisions sometimes which they shouldn't be actually, but when they are making such decisions, how does it work, and how do you
So I,
basically.
Swapnil, I'll talk with the start of the thing. You have a certain DNA, I have a certain DNA, right? And every organization has a certain DNA. So that DNA understanding of that organization is very important. So if you are talking to, I actually never wanted to mention any name of the customer. ISRO is easier to understand, but I want to name like one customer, Indian Air Force, and we struggled like really bad with them. And they said, "All right, we have these many parts of Sukhoi 30, and let us build them." The main problem is, like, they don't understand the technology. They don't understand the actually using the end product, how to use it. They always used to order. It used to come from Russia. They used to directly utilize it, but they got a mandate of indigenization, and that's where like a certain case cannot be developed, right? Until
Hmm.
unless you change the DNA of the end user, uh, uh, and those cannot be changed today. It has to take a certain lifetime to change those DNA, and that's why like the success of a customer you hear, it is because of the DNA of that organization. That's it.
Right.
So if you talk about the Siemens of the world and the GE of the world, the DNA changed like 20 years back, and today you are seeing those success stories. So it's like an iceberg. You just see the top of the end, and everybody talks. So I just wanted to ask, like, do anybody know which company has the biggest AM setup in the world? Can anybody name it? If you want, like, this is a trivia I was just wanted to just talk about.
Yeah, we can see in the chat.
So if somebody can name this, I can say two companies, and you might not actually think that these two companies might be. No, not Boeing. No, not Emerson and GE.
Wow.
So have you heard a company called SpaceX?
Yeah.
Have you heard a company called Striker? Yes, Priyesh named it right. So these companies have the biggest setup in the world, and they don't talk about it. They just talk about like utilizing the final end components. So they are selling not just the technology and the case studies, they're selling a final end use components. So you can understand, being silence is not that you are weak. Being silence is like how strong you are. So so, so that's where like you have to understand how you are perceiving the technology for yourself. And the amount of in the new Falcon, the amount of the amount of 3D printed component is more than what relativity space is trying to push. So relativity space doing a lot of PR work and a lot of so that is where like uh, a forum like IMF can work, is like filtering that marketing jargons, the marketing thought process to actually the end use kind of a thing. And that's where like as a successful country, for the leading technologies, we can push the agenda.
Okay. I have one last question for you. Being in India, we have a lot of powder manufacturers. There are machine manufacturers. There are people who are amazing with the software, and other possibilities. What kind of synergy you think we can build, according to you, because with the kind of exposure that you have, we can build here in India, and maybe, and build a state of the art or world class, AM infrastructure to serve the world. Is there any possibility? Can there any role be played? Can we work together?
So, Swapnil, I'll start with you because you are a machine manufacturer, and anything starts from a machine manufacturer. So, what kind of government support did you get when you started your company? I just wanted to ask you.
Yeah, there was almost nothing. Yeah.
Exactly. So, and you take any of the bigger OEMs around the globe, they started with a grant. They started as a research project, and they started as a project. And you cannot be a technocrat until unless you have that freedom to be something. And I was last week. I was with one of the customer, one of the leading global manufacturing giant Acres. I was with the founder. We were having dinner, and he told a basic point, a basic cultural difference between Indian to a Jew. So he said the difference between a Jew and the most successful people around the globe are Jews, and you can understand. So what they used to do is like they used to marry the richest person of that village used to marry to the wisest person of the village. So that wisest person can continue with his research, and the overall overheads can be taken here by the richer person. So that is very important, and I think that's where the major setback has been Everybody is like Indo MIM. If you take yourself, if you take Intech or Amaze, wonderful work and wonderful things you have done. But the major thing is like it has been in islands, in silos. So we had in February a meeting with the CSIR labs all across the country, and which actually should spearhead something like this. Those are like front offers of the country, and those should think on something on those lines. But their major agenda is like, can we do research, physics level research? We are like, that has been done. Why are you copying a Japanese paper into your this thing? Why don't you fund somebody who's actually trying to make a difference? And that's where the difference starts. And that's where like right now people are thinking on the research level. And if until unless NCAM or the national strategy for additive manufacturing gets everybody all along and decide on pushing the agenda for actually increasing the manufacturing, not just additive manufacturing, as
Right.
manufacturing. And I think we will not be able to do something. And basically, the customer focus in India, the bigger problem is, other than automotive or white goods, none of the designing work, like basic designing work, is done in the country. Those are mostly done in the Japanese part of the world or European part of the world or the American part of the world. And until unless we start doing designing for manufacturing, or we cannot say that we are operators of the machine, until unless we say we are the machinists of the machine. So a CNC operator to a machinist is like the biggest difference, right? A CAD
Yeah.
operator and a designer is a biggest difference. So that is the thought process right now. You go on LinkedIn, you'll find CAD designers like this software, that software, this software, that software, but nobody is actually, if you give them something basic, they will not be able to design. So from there, if we don't start creating that basic level knowledge base, is very important for us.
Right. Super amazing. I guess it was very, I think a lot of inputs from you coming in are they're going to help all the members, and we can learn from you and also through your experience. I would like to especially invite you for many such talks and discussions on IMF platform. We still have many questions here on the list, but I'll have to stop here because of the time limitation that we have. Thank you, Ankit, for
Thank you.
being
Thank you
part
for
of this,
inviting.
session today, and accepting to speak here and be with us on IMF. We would like to be in touch with you, and then understand, and maybe we have another meetups, physical meetups as well coming in. And we would want you to be there,
Thank you.
as well. So thank you for your amazing presentation today.
Thank you.
Yeah. Okay. So, coming up with our next session, is it's going to be a panel discussion between some of the great minds in AM service bureau industry. And these people don't need any introduction. You all know them, but I have to introduce our moderator here for this panel discussion. He is Parth Gathani. He's president of IMF for current year, and he's an aerospace engineer himself from University of Sydney, and he's co-founder and CEO of Trivimus Technology. It's an integrated 3D printing and product development company. Um, over to you, Parth, and yeah.